Hello everyone, welcome to Ketson. Myself Kavipriya and this is Sherina. Today அவங்க challenger meet game பண்ண போறாங்க thermodynamicsல. என்ன டாபிக்னா steady flow energy equation and then applications 6 applications இருக்கு. First nozzle, diffuser, turbine, compressor, boiler and condenser.
So firstly we'll be seeing about what is steady flow energy equation. In steady flow energy equation we'll write it as first enthalpy H1 plus kinetic energy 1 plus potential energy 1 plus heat added. It is equated to another equation, that is specific enthalpy 2 H2 plus kinetic energy 2 plus potential energy 2 plus work done. So this can be written as H1 plus kinetic energy can be written as half mc1 square. Potential energy can be written as gz1 plus work done heat added at control volume. So it is equated to specific enthalpy 2 plus kinetic energy. As we saw here, it can be written as mc2 square plus potential energy is gz2 square plus work done at control volume. So when we take this as for unit mass, when we take this equation for unit mass, it will be as H1 plus half C1 square plus GZ1 plus QZV, which is equal to H2 plus half C2 square plus GZ2 square plus work done at control volume. So this Z shows height and this we know it shows enthalpy, and this Q is heat added at control volume. Here H2 is specific enthalpy and this is work done at control volume. So this is steady flow energy equation. Now we'll be seeing about the 6 applications in which steady flow energy equation is applied. Firstly, nozzle. As we all know, in nozzle, it is an accelerating device. As it is an accelerating device, kinetic energy in nozzle increases, volume increases, while the pressure energy in nozzle, it decreases and the pressure also decreases. So when we see about nozzle, this energy equation for nozzle is, in this we will neglect C1 and we will take just C2. So it will be C2 is equal to 44.72 square root of H1 minus H2. So this will be the energy equation of nozzle. Second one is diffuser. Diffuser is a decelerating device. Diffuser is a decelerating device, and in diffuser it will be straight opposite to nozzle. That is, here kinetic energy, here we will write another one point to enthalpy. Enthalpy also increases in nozzle, and here kinetic energy decreases, volume decreases, while pressure energy increases and pressure too increases. Here enthalpy increases, the same as nozzle. So in this we will see the energy equation. In energy equation for this, we will neglect C2 and we will take C1. Unlike here, we neglected C1 and took C2. So C1 will be equal to 44.72 square root of H2 minus H1. Here H2 will be greater, here H1 will be greater. So this will be the difference between nozzle and diffuser. Next one is turbine. Turbine, we all know it is a work producing device. In this work producing device, pressure decreases and enthalpy decreases. So this is the properties of turbine. Pressure decreases and enthalpy decreases. So work done in turbine will be equal to H1 minus H2. Here H1 will be greater. So this is all about turbine. And next when we come to compressor, compressor is a work absorbing device. Work absorbing device, and the opposite of turbine happens here, because we all know turbine is a work producing device and compressor is a work absorbing device. So here pressure increases and enthalpy too increases. So here the work done in compressor or pump will be equal to H2 minus H1. So this is all about compressor. Now we will come to boiler. So boiler is a heat addition device. Since it is a heat addition device, H1 will be always less than H2, because when we add heat, the lower initial temperature will be always less than the final temperature. So enthalpy also in the same way, H1 will be always less than H2. So the Q will be equal to H2 minus H1. This is all about boiler. While condenser is opposite of boiler, that it is a heat absorbing device. Here H1 will be greater than H2. So when we absorb heat, the initial temperature will be always greater than the final temperature. So Q will be equal to H1 minus H2.
ஸோ இன்றைக்கான டாப்பிக்கில் வந்துட்டு ஸ்டெடி ஃப்ளோ எனர்ஜி ஈக்குவேஷன்னா என்னென்ன, அதோட ஈக்குவேஷன், தென் யூனிட் பர் மாஸ்க்கு எப்படி ஈக்குவேஷன் மாறுதுன்றதை சொன்னாங்க. சரி, ஒரு டேர்முக்கான நேம்ஸும் சொல்லிட்டாங்க. நெக்ஸ்ட்டு அப்ளிகேஷன், நாசலோடைய எனர்ஜி ஈக்குவேஷன், டிஃப்யூசரோடைய எனர்ஜி ஈக்குவேஷன், டர்பைனோடைய ஒர்க் டன், அப்புறம் இது கம்ப்ரஸருடைய ஒர்க் டன், பாய்லருடைய ஹீட் ட்ரான்ஸ்ஃபர் அண்ட் கண்டென்சரோட ஹீட் ட்ரான்ஸ்ஃபர் ஃபார்முலாக்கெலாம் அழகாக எக்ஸ்பிளைன் பண்ணாங்க. இது அழகாக சொல்லிக் கொடுத்த ஷிரினாக்கு தேங்க்ஸ்.
தேங்க்யூ.